logic gates and Boolean algebra. I will teach you the super easy way to learn logic gates and exam questions. Also, you will learn the basic concepts of Boolean algebra. So watch this lecture till the end and you will learn something awesome. Firstly, let me teach you binary digits. Well, the word bi means 2. We use only 2 digits, 0 and 1, in a binary system. The digit 0 represents low value of or false, while the digit 1 represents high value on or true. This is the complete philosophy of binary digits 0 and 1. I hope you know that every computer uses the binary digits 0 and 1. Now I will teach you the basic concept of Boolean algebra only in one statement. I mean, in Boolean algebra, we use binary digits and 1 plus 1 is equal to 1 because there is no other digit. Let me repeat it. In Boolean algebra, we use binary digits and 1 plus 1 is equal to 1 because there is no other digit. Hence, if you learn this basic concept, you can easily learn Boolean algebra. For example, consider addition of binary digits in Boolean algebra. We know that 0 plus 0 is equal to 0. 0 plus 1 is equal to 1. 1 plus 0 is equal to 1. 1 plus 1 is equal to 2. But in Boolean algebra, there is no such digit like 2. So 1 plus 1 is equal to 1. Secondly, consider multiplication of binary digits in Boolean algebra. Remember that 0 in multiplication is a hydrogen bomb and it finishes everything. Let me repeat it. 0 in multiplication is a hydrogen bomb and it finishes everything. Like 0 into 0 is equal to 0, 0 into 1 is equal to 0, 1 into 0 is equal to 0, and 1 into 1 is equal to 1. Thus remember that in Boolean algebra, all the mathematical operations are the same except 1 plus 1 is equal to 1. Now if you want to learn logic gates, you must learn Boolean algebra. Without it, you cannot learn a single concept of logic gates. Hence, I will teach you some basic concepts of Boolean algebra. Firstly, let me teach you addition of binary digits. Let a is equal to 0 or a is equal to 1. Now a plus 1 is equal to 1. We know that a is equal to 0 or a is equal to 1. So 0 plus 1 is equal to 1 or 1 plus 1 is equal to 1. Secondly, a plus 0 is equal to a. We know that a is equal to 0 or a is equal to 1. So 0 plus 0 is equal to 0 or 1 plus 0 is equal to 1. Also, let me teach you the multiplication of binary digits. Let a equals 0 or a equals 1. Now a into 1 is equal to 1. We know that a is equal to 0 or a equals 1. So 0 into 1 is equal to 0 or 1 into 1 is equal to 1. Secondly, a into 0 is equal to 0. We know that a equals 0 or a equals 1. So 0 into 0 equals 0 or 1 into 0 equals 0. Hence addition and multiplication of binary digits are very simple. Now let me teach you the concept of inverse in Boolean algebra. For example, consider low value. If I ask you what is its opposite value, your answer is simple. Its opposite is high value. We know that 0 represents low value and 1 represents high value. So the inverse of 0 is 1 and that of 1 is 0. For example, if one binary digit is a, its inverse is a bar. Thus remember that bar on any variable represents inverse value. Now a plus a bar is equal to 1. Let a equals 0. Can you guess the value of a inverse? Well, a bar represents the opposite value of a equals 0, a bar equals 1. Because the opposite value of 0 is 1 and vice versa. Now 1 plus 0 is equal to 1. Hence we say that a plus a bar equals 1. Fourthly, a double bar equals a. For example, let a equals 1. I inverse the value of a. I get a inverse equals 0. I again inverse the value of a. I get a double bar equals 1. Hence the initial value of a is equal to 1 and that of a double bar is also equal to 1. Thus we say that a double bar is equal to a. The simple trick is always cancel the two bars. Fifthly, a dot a bar equals 0. Let a equals 1 and a bar becomes 0. Now 1 into 0 is equal to 0. Thus a into a bar equals 0. Thus noted down all these basic concepts of Boolean algebra. Now I will teach you one advanced concept of Boolean algebra. A plus b whole bar equals a bar plus b bar. Let me also teach you its proof. Firstly, consider left hand side. At the left hand side, we have a plus b whole bar. Now consider values of a and b. Let a equals 1 and b equals 0. Because here we can use only these two digits. I will solve this question in two steps. In the first step, I will find a plus b. In the second step, I will find inverse of a plus b. Now in the first step, a plus b is, the value of a is 1 and that of b is 0. 1 plus 0. I get 1. Hence the value of a plus b is equal to 1. In the second step, we have to inverse the value of a plus b. We know that a plus b is equal to 1 and its inverse is 0. Thus at the left hand side, a plus b whole inverse is equal to 0. Let this is equation number 1. Now at the right hand side, we have a bar dot b bar. We know that a equals 1 and b equals 0. Now the value of inverse a is equal to 0 and the value of inverse b bar is equal to 1. According to the given statement, we have to multiply a inverse and b inverse. I write 0.1. I get 0. Thus the value of a bar dot b bar equals 0. Let this is equation number 2. We can see that equation number 1, a plus b whole bar equals 0 and equation number 2, a bar dot b bar is also equal to 0. Hence equation number 1 is equal to equation number 2 and left hand side is equal to right hand side. Therefore, we say that a plus b whole bar equals a bar dot b bar. Similarly, a dot b whole bar is equal to a bar plus b bar. Now I will teach you my personal and super easy trick to remember these two equations. Let I write a plus b whole bar and a dot b whole bar. I always write a bar b bar, a bar b bar. Secondly, if there is plus, I convert it to dot. If there is dot, I convert it to plus. This is the super fast easy trick to remember these two equations. Now it is time to teach you the easy concepts of logic gates. Firstly, let's understand the basic purpose of a gate. Consider this open door and this closed door. In case of open door, you are allowed to pass through. In case of closed door, you are not allowed to pass through. Similarly, consider these logic gates. Logic gates either do not allow electrical signal to pass through or logic gates allow electrical signal to pass through. I mean, we use logic gates in order to allow or block electrical signals or digital signals to enter into the circuit. Thus remember that we use logic gates to on and off any digital circuit. Now what are logic gates? Well, consider this logic gate. We give two inputs to any logic gate and we get only one output. For example, I give 1 and 1 as inputs to this logic gate. We know that 1 represents on. This logic gate will give us 1 as output. so it allows the digital signal to pass through. Secondly, consider this logic gate. I give two inputs to it, 0 and 0. We know that 0 represents off. This logic gate will give us 0 as output, so it does not allow digital signal to pass through. Thus we give two inputs to a logic gate, it performs a Boolean function and give us an output. Therefore, we define logic gates as the digital devices which perform Boolean function by taking two inputs and giving an output. Let me repeat it. The digital devices which performs Boolean function by taking two inputs and giving an output. Remember that logic gates work on the principles of Boolean algebra. Secondly, logic gates are made up of diodes and transistors. Thus remember that with the help of Boolean algebra, logic gates either allow or block signals in order to enter into the circuit. Now what are the types of basic logic gates? Well, there are 5 universal logic gates. Firstly, we will learn 3 logic gates like OR, AND, NOT. In case of OR gate, I halfly cut the O. I draw it here and I curve this side. We always give 2 inputs to the logic gate like A and B. Use these inputs to give us an output Y. Now the question is, how this OR gate process these 2 inputs A, B? Well, OR gate add these 2 inputs A and B. So I write output Y is equal to A plus B. Now consider this truth table. We know that the possible value of AB is either 0, 0, 0, 1, 1, 0 or 1, 1. What about the value of Y? Well, OR gate always sum up the value. 0 plus 0 is equal to 0, 0 plus 1 is equal to 1, 1 plus 0 is equal to 1, 1 plus 1 is equal to 2. But in Boolean algebra, there is no such digit like 2. So 1 plus 1 is equal to 1. Thus this is the truth table of OR gate. Secondly, in case of AND gate, I take this T, I write it here. I give 2 inputs A and B. It gives us an output Y. Now how this AND gate process these 2 inputs A and B? Well, in case of AND gate, this T reminds me dot. I mean Y is equal to A dot B. So AND gate multiply A and B to give us an output Y. Now consider this truth table along with the possible values of A and B. What about the value of Y? Well, AND gates multiply A and B or AND gate multiply inputs. 0 into 0 is equal to 0, 0 into 1 equals 0, 1 into 0 equals 0, 1 into 1 equals 1. Thus this is the truth table of AND gate. Thirdly, in case of NOT gate, I halfly cut the N and I write it here like this. Also, I select this O and I write it here. I give one input A to NOT gate. Remember that NOT gate inverts the value of input. So its output is A bar or Y equals A bar. For example, consider this truth table. The possible values of A is 1 and 0. What about the value of Y? Well, just inverse the value of A. The inverse of 1 is 0 and that of 0 is 1. Hence this is the truth table of NOT gate. Now the fourth gate is NOR gate. We take NOT gate and OR gate to form NOR gate. Here I draw OR gate and I just put only small circle in front of it. This is the NOR gate. Now listen carefully. The OR gate will add the inputs A plus B and the NOR gate will inverse it. Let me repeat it. The OR gate will add the inputs A and B and the NOT gate will inverse it. So I write OR gate Y is equal to A plus B, then I put bar on it, because NOT gate inverse it. What about its truth table? Well, consider these possible values of A and B. Now OR gate will add them. 0 plus 0 is equal to 0, 0 plus 1 is equal to 1, 1 plus 0 is equal to 1, 1 plus 1 is equal to 1. Also we know that the NOT gate will inverse them. Inverse of 0 is 1 and that of 1 is 0. I write 0, 0, 0. Thus this is the truth table of NOR gate. The last and the fifth gate is NAND gate. We take NOT gate and AND gate to form NAND gate. Here I draw AND gate and I put only small circle in front of it. This is the NAND gate. Now listen carefully. The AND gate will multiply the inputs A and B and the NOT gate will inverse it. Let me repeat it. The AND gate will multiply the inputs AB and the NOT gate will inverse it. So I write AND gate y equals A dot B, then I put bar on it because NOT gate will inverse it. What about its truth table? Well, consider these possible values of AB. Now AND gate will multiply them. 0 into 0 equals 0, 0 into 1 equals 0, 1 into 0 equals 0, 1 into 1 equals 1. While the NOT gate will inverse them. We know that inverse of 0 is 1 and vice versa. I write 1, 1, 1 and 0. Hence this is the truth table of NAND gate. Therefore, using this simple way, we can easily learn all logic gates. Now let me teach you that how to write function for any logic gate. Well, consider these two systems. Firstly, I always spot the type of logic gate. For example, in the first system, this is AND gate, this is OR gate. Now two inputs A, B are given to AND gate. We know that AND gate will multiply the inputs. So we get A dot B as an output. Secondly, A dot B and this C is given as input to OR gate. We know that OR gate adds the inputs. It adds A dot B plus C. Hence we get Y equals A dot B plus C. On the other hand, this is NAND gate, this is NOR gate and this is OR gate. Now two inputs A, B are given to NAND gate. The AND gate will multiply it A dot B, while the NOT gate will inverse it. I put bar on A dot B. Secondly, two inputs C, D are given to NOR gate. The OR gate will add it C plus D and the NOT gate will inverse it. I put bar on C plus D. Thirdly, this OR gate receives two inputs A dot B whole bar and C plus D whole bar. We know that OR gate will add the inputs. We get A dot B whole bar plus C plus D whole bar. Thus the function of this system is Y equals A dot B whole bar plus C plus D whole bar. Therefore, using this simple method, we can easily write function for any logic gate system. Finally, let me teach you some exam questions. What will be the value of A and B for the Boolean expression A plus B whole bar into A bar dot B bar equals 1? Well, the question is, what value of A and B should we take so that left hand side becomes equal to the right hand side? Let I take A equals 0 and B equals 0. Now consider left hand side. A plus B whole bar into A bar dot B bar. I put the values of A and B in it. I write 0 plus 0 into whole bar dot 0 bar dot 0 bar. We know that 0 plus 0 is equal to 0. I write 0 bar into, also we know that 0 bar or inverse of 0 is 1. I write 1 dot 1. Now this 0 bar means that inverse of 0, which is 1. I write 1 dot 1 dot 1. We know that 1.1.1 is equal to 1. Therefore, if we take the values of a and b as 0, we get 1. Hence, the value of a is 0 and the value of b is 0. Secondly, consider this digital circuit. This logic gate is equivalent to dash. Well, firstly, I spot the logic gates. This is NOT gate, this is also NOT gate, and this is NAND gate. Now this NOT gate will inverse the input A and we get A bar. Here we also get B bar. Secondly, this NAND gate receives two inputs, A bar and B bar. The AND gate will multiply it. We get A bar dot B bar, while the NOT gate will inverse it. We get A bar dot B bar into whole bar. Also we know that A bar dot B bar equals A plus B whole bar. So instead of this A bar dot B bar, I write A plus B whole bar. I get A plus B double bar. Also we know that in case of double bars, we cancel it. We get A plus B. We know that A plus B represents OR gate. Hence this digital circuit is equivalent to OR gate. Thus using this simple method, we can solve logic gate problems easily. I hope that you have learned all about logic gates.